So, good evening, guys, again. So, in the meantime, let's just wait for a couple of minutes so that we accommodate everyone. In the meantime, let's quickly summarize what we have discussed in our last session, right? So, I think we spent most of our time understanding the programming assignment, whatever we got, right? And we discussed the solution for factorial and I hope the rest of you guys tried solutions for the second and third programs, right? Like, have you, if you guys have, can someone share me the solutions? I'll just quickly have a look at it and see if they're fine or not. Yeah, so that is one thing. And still, anyone didn't tried any of this program at all? Any one of you who didn't even tried any of this program till now?
Sir, I did 3 of this, but the revised number one, which is like input and output. When I did that one is like I know how to do it when I do on the paper and division and everything was like perfectly fine. But when I don't know how to put the condition on it, or maybe I don't know. I used the while loop, I used the for loop, and it was not working, so I messed up everything. So can you show me how to do it? That one, the second one, third one I did.
Okay. Okay.
Third, the second one I know, but I don't know how to put the condition on it in a while loop.
Okay.
This is the one, yes.
Yeah, so I'm sharing you guys the solutions. Just take that. Okay. Go through it. If you couldn't understand, then just let me know so that we will discuss this further. I have
Okay,
put some
I'll take
comments
picture
here.
and I'll do myself.
Yeah, I have put some comments here so that you will understand for what sort of thing we wrote that condition and all, right? So both of them we have used loops, right? Both the solutions for both the programs. So just go through these solutions and just go through them and
So
let me
what
know.
what situation we use that program? I mean, in the practical life, in how do we implement that kind of program?
Well, see,
And what?
the goal of this particular assignment, whatever I shared you, it is to give you a good understanding of all the concepts we have discussed till now. We have spoken about data types, right? We have spoken about data types. We have spoken about control statements, loops, conditionals, for, and all, right? And we have also spoken about operators, arithmetic operators, and relational operators, and all these things, right? The general concepts. So the idea of this program is to give you a comfortable approach to start programming into Java. Okay, so ideally in real world, no one will ask and come you to write a typical program like this. It's just that how you uh, tune your mind to Java programming world. So the goal of this program is to make you just do that, to start getting comfortable into the Java programming. That's all, right? Nothing much. But in the remaining classes, the next set of assignment, whatever I am going to give you, they are definitely going to be helpful in your real time. Yeah. Okay. So you can think these assignments as just a beginner assignments, right? Just to make you guys comfortable. These are all just simple. If you have a basic analytical thinking, you can come up with the approach. It's just matter of writing this code in Java is what I want you to guys get comfortable with. Okay. Now, having said that, I answered your question, right, Asha?
Yeah, I got it. I understand. Thank you.
Yeah. So having said that, I just want to let's quickly summarize a couple of theoretical concepts we have discussed in our last session. So in our last session, what we discussed, guys, anyone of you give me a couple of lines on what we have discussed in our last session?
Yesterday one?
Yeah. Day before yesterday. I think yesterday we didn't connect, right? So day before yesterday. We discussed a couple of critical concepts, right? What was it? So we spoke about the difference between a break. We talked about jump statements alone, right? And we looked at a couple of programs demonstrating the difference between break and continue. So what exactly is the difference between break and continue?
So when you use the loop, and I mean, after condition, when you use the break, that means that condition is true. After that, it's not going to be run. And that block of the codes just for, am I right?
Yeah, go on, yeah.
Yeah. So that block of code is for use for that break. After that, it's not going to be, it's a Boolean. It is true or false. That comes, I think so. Or maybe I confused.
Okay. So basically break is like within a loop. When you use a break statement, break will take effect only when if you use it inside a loop. Okay, if you are writing break somewhere openly, it won't have any meaning. Okay, just keep that in mind, guys. If you use break within a loop, see, when you execute that break, it depends. You may put some condition. If you may put that break inside an if conditional, and based upon certain condition evaluating the true or false, you can execute this break statement, right? When you execute the break statement, it will immediately come out of the loop. Whatever lines of code that is present after the break, it will not execute. Okay, it will immediately, suppose your loop has to go 10 times, right? And when it is going on the third time, third iteration is happening, some condition got evaluated to true and the break statement got executed, right? In that moment, in the third iteration itself, your loop will terminate abruptly. It will not go through fourth, fifth, six subsequent iterations, and also whatever lines of code that is present after the break will not be executed, right? That is the break. Now what is the continue? What is continue?
Continue is that break the code and the end of the loop. It's a I know, but I don't know how to explain. I know I can work, but I don't know how to explain.
Yeah, if you compare with break and continue, right? Break will
it's the
immediately stop
same
the
way
loop iteration, right? Whereas continue will not stop loop iteration, right? That's the only key difference. But the catch here is both break and continue, whatever that is lines of code that is present after the break and continue inside the loop, both of them will not execute. Okay, break will halt the loop termination itself, whereas continue will just skip the lines of code that is after the continue within the loop in that particular iteration, and it will continue with the next iteration. Okay, that's what continue is about, right?
So if we want to use continue, if we want to use continue, so we need to use the nested loop for that.
Yes. See, both break and continue are used within a loop. If you use them outside loop, they don't have any meaning. And when you have nested loops like, when you have nested loops like while loop inside while loop inside while loop, like the immediate loop will take into effect. Like if you have a one loop over the other, one loop over the other, it doesn't mean they will come out of all the loops. Only the immediate loop, it will come out. Okay. Understood, right?
Yes.
So today, guys, whoever is not speaking, please go on mute. So, you see, if still anyone is pending doing these assignments, please do it, okay? Or take the solutions that I shared. I think in first class, one of you guys itself shared me the solution, so you can consider that a solution for the first program. So I want you to go through the solutions, tune your thought process, and then come back to me with any questions, right? So, but next assignment, I want all of you guys to do it without fail, okay? Yeah, I think till now, whatever concepts we discussed with Java are very basic. It's like they prepare ourselves to get into the actual concepts of Java, the object-oriented concepts of Java, right? So today we are going to discuss them. So we are going to talk about Java classes today. Okay, and whatever we discuss from now on are the most important concepts which are kind of important for interviews also. Okay, so whatever I discuss, so whenever I start from here, I'll point out certain concepts which are primarily important for the interview. So I would ask you to be cautious on those, right? So having said that, uh, like I want to ask you a quick question before we start this, right? So what are all the object oriented principles we discussed, right, in our initial classes? What are all the object oriented principles, guys? Sorry? What are the object oriented principles? We spoke, right, in our first class. Any object oriented programming language will follow certain principles, right?
That's
abstraction,
Right. Go on. Abstraction,
encapsulation, inheritance, and polymorphism.
polymorphism. Yeah, that's right. Thanks for that. Yeah. So those are the object oriented principles, and there are two more, right? The class and also the object. So
Yeah.
your object oriented principles are object, class, encapsulation, abstraction, polymorphism, and inheritance, right? These are your primary object oriented principles. So having said that, we are going to talk about classes in Java. So I mean, we have been writing classes from start, right? If you see the programs that we were writing, uh, like say the factorial program which we wrote in our last class, it basically started with a class like this, and inside that it has a main method, right? So these are very you can say rudimentary form of the classes, right? Very simple forms. So if you look at here, we inside a class we are putting a main method which is basically starting point of our application, right? Main method basically acts as starting point, entry point into our application. But if you talk about real world application, it would contain hundreds of classes, thousands of classes, right? Thousands of Java classes. And out of those 1,000 classes, you will only have one class which will basically contain the main method. That is the entry point. Okay. So not all 1,000 classes will have main method. Only out of your all 1,000 class that basically cater to your application, you will find one class having main method. But rest of all the classes, they may actually model the actual real world entity mapping in terms of the object oriented principle. So let's just try to dig into these concepts and see how they start. Okay, like starting with let's talk about encapsulation. So what is encapsulation, guys? What do you guys remember about it? Like there's for a beginner Java interviews, right, or probably advanced also, they will ask questions on this object oriented principles. Okay, they will ask you guys what is abstraction or what is encapsulation, how are we implementing, or how can we achieve encapsulation in Java. They'll ask you this question. Okay? These are like very basic, so you should be like prepared for them. Yeah.
Binding of data.
Yes,
Code
encapsulation is binding of data and code together, right? And how can we achieve that in Java? So we achieve encapsulation in Java using class. Class binds the data and code together. Okay. So within a class, you can create the data, right? The variables and your methods, which basically modify the state of those objects, the entities that we create, right? So, simply said, we can achieve encapsulation in Java using classes. So using classes, we can combine the data and code together. Okay, as simple as that. Just keep this in mind. So we are going to talk about classes today. So basically, what is a class? Like in general, a textbook definition would be what is a class? A class is like a template for an object. Okay, and vice versa, you can say an object is instance of class. So basically, class is like a something, a contract. It's like a you can say it's like a logical thing, but object is the actual physical thing that will exist on a computer, which will which will be created from the template of that particular class, which will hold some physical reference within your computer memory. Okay, so that's the key difference between a class and object. Okay, now having said that, in general in Java, whatever class we create, they will have this approach like this. Okay, so you will have a class and you will put some name to it, a class name, and your class will close and start with the curly braces, and inside class you will create some instance variables. Okay. Instance variables, and every line of statement in Java closes with the colon, right? And then here you should also put the data type, if it is character data type or character, or int data type or anything. So I'll just simply say data type. You should also specify the data type, and you can declare any number of variables you want. Okay, depending upon the functionality of your class, like this. Okay. In addition to this, your class will also contain the instance methods. Okay, again, which is basically a return type, right? And what else we are going to return type, and we'll have a method name, and method syntax would look like this. Okay, return type is the type of the value this particular method is writing, and inside here it will contain the parameters list that particular method is accepting. So you can have a number of methods. Okay, so this is a typical of class. You can say a blueprint syntax how any class in Java would look like. Okay, so this is the format, and if I go back to the sample class that we wrote here, right? This contains a main method, right? So let's pick another class if we wrote. Okay, I think whatever class all we wrote has main method. So we'll create one class now. Okay, so to create a class, we will be using this class keyword. Okay, and then in front of that you will put some access modifier, the public, private, and but for class it's always public, right? There is no point of having private classes because nothing can access it, right? So your classes will always be public, but inside your class, inside your class, right? Your variables, your methods, these can be public, private, or protected. They can have any access modifier. Okay, so based on their access modifier, they can be accessed accordingly. And you have a package name, which is basically the folder structure under which this particular class is present, right? So that means within the same package, you can't create a class with another class with the same name factorial. If you see, let me just try to create another class here with the same name factorial. It will not allow. It says what type already exists, right? I am creating com Java training 1 package. But what if I try to create a training folder? Will it allow? What do you guys think? Will it allow or it won't?
Yes.
It will allow. Okay. If I say factorial here, it will allow, because Java considers class with their name with their fully qualified name, which is the package name com.java.training.factorial. The name of this class is com.java.training1.factorial. Okay, if you see, you have a class with same name here and here both. Okay, so Java uses the fully qualified name So you have it that way. So look at this box class. If you see, this is how a typical, when you actually start the real world programming in your actual project, so you kind of create this kind of classes. Okay, you kind of map your real world objects to this kind of classes. Okay, so having said that, we'll just talk about each and every concept that is there in class. Okay, so before that, I'll just try to create a simple class. I'll take this itself, the box class. Okay, I'll remove this. So if you see the box class, it basically has 3 variables, right? A length, height, and width, right? So typically a box like this. I'm just trying to map a box like this in our Java. Okay, you will have a box like this, right? So which will contain a typical box like this. Okay, this is your length, this is your height, this is your width. Okay, length, height, width. So now my first question. Okay, uh, now that we create a class, does class have any physical significance on the storage? No, right? In Java, it just doesn't understand. It's just like a blueprint. It's like a logical representation. But what will have the actual meaning? Object, right? So I will say class demo. Main method here. Okay, and to actually create a physical copy of this box into Java memory, we would create an object. Okay, so how I will create an object is, look at the syntax that I'm writing now. Okay, so I need to tell the type. So now see, basically when you are creating a class, that means box itself can be is a data type. Like int, how int is a data type, box itself is a data type. Okay, so I can box and you create some reference for that. You can say box object. Okay, something like this. Box object. Okay, box object equal to, we will use this new keyword, new and box. So the moment I do this, okay, the moment I do this, now this box object will basically contain the physical reference. Let me just print out this box object. Let's see what we will get. Okay, now I'm running this program. If you see, what is the output we got here? This is the one, right? So if you see, this is the package name, com.java.training.box, the package under which the box class is present, right? com.java.training.box. And then it has some address like this. After @, it has some address like this. So this is the address of the memory, right? The RAM, random access memory, where your box object is stored. Okay, so basically new keywords allocates memory for your box class, right? And it will box class, which is basically nothing but the box object, right? So when you're using new keyword, that's when your class is basically loaded onto the Java's memory, your machine's memory, and it will have some physical significance. Okay, so like the new operator, it will dynamically allocate memory and returns basically a reference for it. which is basically the memory address. If you see 6E8DACDF, that is the memory address, and that memory address, it will be stored in the reference, which is basically the box obj. Okay, so when you say new box, it will allocate some memory. It will return this memory reference, which will be in the box object, and when you print it, it will just print it. Okay, so this box object is just a reference. Okay, so
So when you create a object, then only that address is getting assigned.
yes. So let me just, if I don't use new operator, let's assume that, okay? I'm not using new operator. I just simply created a reference for it. Okay, box obj, box obj. What it says, it first of all basically throws error. It says initialize variable. Okay, let's initialize to null. Null doesn't have any significance. Okay, but when I execute it, it will just print null only. Okay, it doesn't have any reference. It hasn't been created in memory. So using new keyword, we will create that object, which will be then created in the memory. So let us just try to understand what is happening in the backend when you put new keyword. Okay, so basically your Java process, right? JVM. Whenever you start it, it will basically take your RAM, right? Like you have 16 GB of RAM, for example, right? And you gave your Java program, say 2 GB of RAM. You tell Java, please use out of my 16 GB, you are free to use 2 GB. Okay, you will tell Java to take 2 GB RAM. So when you say 2 GB RAM, you gave 2 GB RAM to Java. Java basically divides the entire 2 GB into its own categories. Okay, like Java divides your entire 2 GB RAM. Okay, 2 GB, whatever you gave, it will kind of do its own classification of that particular memory. Okay, so 2 GB, right? So you have 2 GB memory which you gave to your Java program. So your Java will basically divide your memory, okay, into multiple chunks like this. Okay, it can divide like this. It will divide into multiple categories, and each memory area is called a different, will have a name. One particular memory area is stack memory. Okay, and this memory, you can say the biggest one is heap memory. Okay, stack memory and heap memory. The other memory areas are called method area, PC registers, and all. So we'll not get into those much technicals, but we will focus on stack and heap for now. Okay, so I'll just remove this. So basically, whenever you create a box object like this using new keyword, right? Using new keyword, your Java will first create this object in the heap memory. Okay, inside the heap area of its memory. Okay, so here it will create the box object. This is the box class. Okay, this is basically our box class. Okay, now what are these three segments is nothing but it contains the three variables, right? And this is what having the actual memory address, this address, whatever it got printed in the program, right? This address is the memory address of which, where this particular in memory, where this particular object got created. Okay, so this is your heap memory. And now you have a stack memory also, right? So in stack memory, stack is a typical data structure in Java. Okay, like if you are anyone from computers background, you would understand. Stack is like, you can think it as a stack is a kind of a data structure which will behave in a last in first out manner. Last in first out manner in the sense, suppose you insert something in stack, right? It will insert it here, okay? And next element will be inserted here, and next element here, and next element here. So which one is the item that is last entered into the stack? This item, right? And when you want to remove from the stack, you can't remove anything in between or anything from the bottom. You can insert elements and remove elements from the top itself, right? So last in, this is the last item that entered into the stack. So this will be the first one to remove it. So if I want to remove this object, I have to remove all these first, and then only I can remove this object. So basically, whatever item that is last entered will be removed first. And at the same time, whatever item that is entered first will be removed last. This is a kind of ideology between the stack. Okay, just remember it. Don't dwell into it too much. Basically, Java will use the stack data structure inside the stack memory. So over here, what it will do is it will basically create the reference. Okay, what reference it will create? This reference box obj. Okay, so it will create this reference here. Okay, and it will put a link like this to this memory address. Okay, and inside this you will have all the variables whatever we created, right? Like height, and then length, and width. Okay, so this is how inside memory, inside your RAM, right? Your box object will be stored this way inside stack memory and a heap memory. So this is a reference. This object, box object will hold reference to this memory address, a link. It will create a link so that whenever you say box object, it will return this memory address and you can access this. Okay, so understood, right? Any questions here?
So if we are creating this is one object, right? So suppose if we are creating one more object of same class, then how does it work?
Okay, let's just do that. So whenever you create another object, let's call it as box obj1. Okay, I'll print it here.
It's going to be stored in same address or the different?
No. You will create a new object. Okay, if you see, look at the addresses, they are different, right?
Mm-hmm.
So whenever you create an reference, you can't create a reference with same name. You will give a new reference, no? So this reference will again, first it will create this object, another box object. Okay, so like this, we'll create another box object, and it will have the memory address like this, and it will also contain the height, length, with all these three parameters. Now your box obj will basically come here. Box obj1. Okay, and reference will be created this way here. Okay, so likewise, you can create a many number of box objects. You can create 100 box objects, and 100 will be references will be stored onto the stack, and 100 different new memory addresses will come here. It allocates dynamic memory. Wherever it fits memory is free, it will create there. For next box item, it may create here also. Okay, or it here or here or here or here or wherever. It allocates dynamically. Okay, based on operating system memory management strategies and all, your JVM creates them in your RAM. Okay, understood, right?
Mm-hmm.
Any questions at this moment? So only when basically you are creating an object of your class, it will have some physical significance. Okay, using the new operator. Till then, your box doesn't have anything. So one thing now that we are talking about memory, right? Like, what are we have different memory areas, stack memory and heap memory, right? And out of the 2 GB, normally it will allocate the entire 2 GB to heap only. Okay, stack memory will be on top of that. Stack memory can be 1 MB is enough for stack, okay, because it's just holding the references. Those won't consume much memory. They will consume in bytes. Okay, 1 MB is like 10,000 kilobytes, which is basically 1,000 bytes, right? So which is very basically huge. So it just holds a reference, half byte. So it doesn't need a big memory like heap like 2 GB, right? Here heap will be the biggest memory area because that's where it will store all the physical presence of that particular objects, right? So just take this scenario. Suppose I'll just come to the big picture here. Suppose in your Java application, you are creating so many objects like this, right? So many objects like this you are creating: object 1, object 2, object 3, object 4, object 5. Not just box class. It can be any class. Okay, like this, like this, like this. Eventually, what will happen, guys, if it keeps on creating objects like this? What will happen eventually?
The memory is gonna be more.
Memory will be more. More in terms of what? Like
the size.
Yes, size it's 2 GB. But what is, yes, you're coming there, but you're missing the actual point. What will happen?
It will run out of memory.
Yes, will run out of memory, right? It will be used up eventually. Yes or no? Your entire 2 GB will use up. What will happen then?
Program crash.
Yes, your Java program, your big e-commerce application, whatever you build using Java, will just simply crash, right? How can we avoid this? There comes my next question. How can we actually avoid this? So if you take a typical programming language that are there before Java, like C, C++, right? It's responsibility of us programmers like you and me to ensure that once we create certain object, we should manually write a line of code to remove it. So it was basically a programmer's responsibility. But with Java, I told you, right? What is the best thing about Java? In our very first class, I told you about one concept. Java manages the memory management automatically using what? It uses something. Anyone remember?
We can minimize reusing the same code instead of creating a different object.
And see, that's not the case, right? Like, say, for example, if you have 100 boxes, every box, one box is a square box, one is a rectangle box, one is a cube box, or anything. Every box will have its own values of length and height and width, right? Yes or no? So you may need thousands of objects to do something. In that case, what you will do? See, reuse and all, it's about efficiency. Okay, that's correct in a way, but it's about efficiency. It's about being efficient. But how can we actually minimize this, right? So basically, like as I was saying, programming languages garbage collection. Yes. So Java has something called garbage collector. Okay, the garbage collection concept. So which is basically automatically takes care of this memory management. Okay, how does it takes care is, suppose in the next step, so let's just try to understand how does Java takes care of the memory management. Okay, right?
It's a garbage collector.
Yes. So languages like C, C++, I said programmers like you and me are responsible for removing certain things from the memory. Okay, but in Java that is not the case. Okay, so basically it will work on this stack frequently. It will try to insert new items, remove old items and all, right? So basically what will happen, the moment this program's execution is complete, that means it will start at this line, it will execute 5th line, so on this line and this line and this line and this. When it touches here, can we say this program execution is completed? When it touches this line number 15, it completes, right? Yes or no?
16.
Sorry?
The line
Yeah,
of 16. Complete.
Yeah. Yes. Okay. Line number 16, whatever it is. We can say the program execution is completed, right? So then what this garbage collector will do is it will remove these references from the stack area. It will remove box obj1, box obj2, and these links will be removed, destroyed. Okay. Understood, right? Like it's not garbage collector, it is just how your JVM behaves. As soon as it finishes the execution, it will remove these, it will pop these references from the stack. So these links are also destroyed. So this links, this objects, entire thing is removed. Now JVM, your Java virtual machine, runs the garbage collector process. How frequently it will run, when it will run, it's completely its own decision. Okay, as a programmer, you and me can call it manually, but it's not needed. Your Java is intelligent enough to understand the overall memory and when to run garbage collector process. So every time it will run garbage collector process on heap memory. Okay, and it will find, okay, if this object at this particular memory address, does it have any link to stack reference? If it has, it will not remove this. If it doesn't have, then it will remove this from memory. Understood, right? First of all, after execution, this will be removed from stack. That means this will not have any references in the stack, right? And when your garbage collector runs, it will find all those objects, which does all those things that we created in heap, which doesn't have any reference to the stack variables in the stack area. So it will find them and we will just simply remove them. That's how your Java does the memory management. Okay, it will free up your memory so that next objects are created, right? Just remember this.
Is it a vice versa?
Vice versa in the sense?
Like in the stack, if we have any object and they will look for their link. So if it is not present, they will remove the object, right?
No, that is not the case. Okay, stack, removing from stack depends on your program's execution. If you executed that program, you doesn't need the stack variables, right? The stack variables are meant only for that particular program alone. Okay, it's like if you have 10 programs, every program will have one stack. Understood,
so
right?
The stack, it's not going to remove.
No, see, it's like I have to talk about a bit more. We have to dig into this bit more, right? So what will happen, I'll just tell you. I got your question or your confusion, right? Like say this program, right? This is one program. Let's assume you have thousands of classes in Java, and every 1,000 classes will have one stack. Every program will have its own stack. Okay, remember that. But whereas heap, it is common for all the 1,000 programs. All 1,000 programs will use one heap, but whereas all 1,000 programs will have one stack here, right? So when that program execute finish, it will remove these objects and it will delete the stack. But who will free the heap? Heap is common for all the 1,000 objects. Okay, your garbage collector will then look for the stack references. If it is not present, it will simply delete them. As simple as that. Understood, right? It's not vice versa. There is a difference between how these two things work together. Okay, is it clear? Okay.
So what if all 1,000 class run at the same time?
Nothing. As long as your memory is there, they will not create a problem. But assume that your heap memory is full. There can be scenario when stack memory is also full. This will also become full. When this memory is full, like whatever be the case, when memory is full, your Java application will simply crash, right? Which it will stop. When it stops, it will throw an exception. When stack memory is out, it will say stack memory out of stack memory, and it will say out of memory for heap. It will throw some exceptions. Looking at that, we will try to resolve it. The first step we need to do to resolve any memory is, people will just simply increase the memory from 2 GB. They will tell the Java process to use more memory. Like you can take 4 GB instead of 2 GB. It will resolve. But underlyingly, we have to identify why my 2 GB is being used. If normally, frankly telling you, all the Java applications, they don't use more than 1-2 GB, like 90% of the applications, because we have to write our programs very efficiently, that whatever objects we are creating heap, they don't live for a longer time. They live only for a short span of time. Okay, understood, right? So that your memory is reused efficiently. Like if your objects are staying in memory for longer duration, that means there is a chance that your memory will be you will run out of memory. It will be used completely at certain point of time, right? If you're creating objects and if you're deleting if they are being removed from the heap within a matter of seconds, then it doesn't matter. No, you can efficiently work in less memory, right? And it is also a programmer's responsibility also to ensure whatever programming they wrote, they write it efficiently, so that we will help garbage collector to free up the memory efficiently. Okay, so if very new beginner programmers, right, they end up writing a code which will basically run your application out of memory eventually. Okay, so experienced programmers will typically address that. I mean, it's a very rare problem, right? But when it happens, there are certain steps we will do. We will try to take the memory dump analysis, and we will analyze which particular Java class is holding more memory in that heap, why it is not getting freed. We'll look at the code, we will do a lot of analysis, and then we will come up with the solution for that. Okay, no solution is kind of straightforward. It really depends upon how the programmer has created a code. Okay? Understood, right? Any questions, guys? Any questions here? Hello? Hello?
Yeah, good.
Okay, fine. So that's all with respect to the new operator, whatever I wanted to. We just touched some of the concepts of Java memory also, right? We got to know about stack memory, heap memory, and the garbage collector. What does it do and all, right? New operator. I think methods we just discussed, right? So I'll come to my Java class here, methods, right? We discussed the syntax of how it would look, right? Suppose in my box class, I'll create one method, right? I'll say public. I want to have a public, and then let me just put this also into. If I don't mention anything, they will have a default access modifier, and my method will return int, and my method will calculate the volume of the box. Okay, like this, and I have to return something, right? Return what will be the volume. By default, let's create one formula like this dot length into this dot height into this dot width. Okay, so if this confuses you, let me just remove this. So basically, I created one method for my box, which is a volume method. By default, I'll put a sysout statement here. That's again. So by default, calculating volume. if you see here, okay, so I have only one method volume, which will basically return the, it's like a default formula for volume I am creating, right? It's like default, it's the product of these three, length and height and width, right? A simple formula, like, which is basically nothing but if you multiply these three integers, you will get integer only. So that way I'm satisfying my return type also, which should be an integer, right? So I'm doing same, or else we can create our own variable again here, vol equal to this, and we will say return vol, and here I'll say integer. Okay. This also fine, right? Or I'll initialize it to 0, or this is how we can write in a different representation. Like if efficient programmer, no need to write this much code. You will just simply put this here. No need to create that one extra variable like vol. Is it needed here? Tell me guys, is that extra volume vol needed? No, right? So this is how you code efficiently as a programmer. Okay, if you try to avoid creating these variables, that means they are not created on the memory now. So you will be using your memory efficiently. Okay, or you can use this, or you can just simply put this here also and just comment. I'm commenting this line. Okay. So my box class has one method, right? So now this is the methods that I'm talking about. So you can create any number of methods you want. Okay. And then constructor. So what is a constructor? We'll talk about constructor. So if you come to your Java program, when you create a new box, something like this box is nothing but an implicit constructor of Java. Constructor is nothing but inside the class, we can have a method which will be containing the same name of that class. Now, if you observe here, the box has a method called box, the same name of class. So this type of methods are called, this is a method again, okay? And this type of method is called a constructor. Okay, so why do we need these kind of constructors? We need them to, if at all you have to initialize when you create an object in first place, right? If you want to basically give it some values, right? Some values you want to assign to length, height, and width when you're creating an object, then you can make use of these constructors to initialize it. Okay, so at this moment let me just comment this once. Okay, so now coming back here, let's take the first one. Okay, box obj. We created box obj. Okay, now I want to give this variable some values, length, width, height. How can I do that? I'll take the object reference and I'll use the dot operator. The moment I put a dot, look at here, what all things we are getting: height, length, width, which are basically these parameters, height, length, width. And I'm also getting the volume method. Okay, I call height and I'll give it some value like 1. Okay, and just put the same 2, 3, width, length. Okay, now print the volume here. I'll say volume of box obj is, so here I'll use this object. Again, I'll use dot operator and I call this volume method. Okay. So once I execute this, now you can see, right, 1 into 2 into 3, which is the calculating volume. So it printed this statement and it returned this length into height into width, which is basically 1, 2, 3, which we gave here. Okay, window, show view, console. Okay, 6, 1 into 2 into 3, 6, the volume which got printed here. Now I'll take the same thing here also. Okay, here I'll give 1 into, or probably I'll say 2 into 2. Okay, now I will take, this is box obj 1, right? This is box obj 1. Now if I execute this, see, this box has volume of 6, this box have 2 into 2, 4 into 2, 8. Okay, so this is how, using the dot operator, you can actually access the individual variables, assign them some values, and using the dot operator itself, you can call the volume also. Okay, so initially we assign these values for the box obj, and then we are calling volume. So when you do 1, 2, 3 like this, box dot height, box dot width, so on in the back end on your memory. Okay, so where is my p brush? Yeah, here it will store these values. Okay, it will store 1, right, 2, width equal to 3. It will store like this. Okay, here 2 for the next object whatever we are creating. Here is also 2, and then here, so it will store these values like this in the memory. Okay, so this is how you can create a class, and using dot operator, you can retrieve its variables and also methods and assign some values and calculate the volume for you. Now, I will show you slight variation. Okay, now if it has a constructor like this, okay, so basically this is called a default constructor. Okay, this is empty constructor, it is also default constructor. So basically, you no need to create this explicitly, right? If you no need to create this, Java will automatically create this explicit constructor for you. Okay, so the idea is to initialize these values, right? Let me just try to print something. Like I created box object, right? Here I'll try to print something before even assigning them. I'll say box dot height dot length dot width. So here at this point, I just created the object. My height, width, length that doesn't have any values. What do you think will be the output here? What will be the output of this, guys? Six. See, it is happening. We are assigning the values at line number 12, right? But I'm trying to print the values of those variables before that.
So 0 is a value, so it would be null because they
null, right? Yeah, that's a good answer. Null. Let's just try to execute this and see. Oh, it is not null, it is 0. Why it is 0? So basically what this implicit constructor will do is, what is the data type of length int, right? For all integer values, they will by default assign a 0, 0, 0, 0. Okay. If it is a string, for example, then it will assign the null values. Okay. So it will contain some default values initially, because when you create an object in the memory, it should contain some value to each and every variable. So using your constructor, we can initialize some default values to it. Okay, so I'll create, you can create a constructors which has arguments also, right? So I can create one constructor like this, and I'll create some, it will take some inputs like this: int length, int width, int height. Okay, and here I'll say I'll assign to this dot height equal to h. Okay, again this dot width equal to w, and this dot length equal to l. This is like in my constructor, I'm passing some inputs. Okay, now When creating objects, I can initialize the values. Now, if I come here, if you see, it is throwing an error. It says constructor box is undefined. That means by default, Java creates the empty constructor for you, which we just saw some time back, right? Like this one, box without any arguments and all. It is creating empty constructor for you. But when you create an arguments constructor like this, Java, it's responsibility of programmer to create an empty constructor. Okay, or else if there are no multiple constructors, Java will by default create this implicit constructor for you. What is a constructor? A constructor is nothing but a method with the same name of class. That's it, as simple as that. If you see now, we have two constructors. One is the default constructor and another one is the parameterized constructor, right? Now this error is gone. Okay, but if this method is not there, and you no need to create this. Java will implicitly create a no argument constructor for you. Just remember that. Now that we have a new argument based constructor, if I try to create a third object, okay, let me just create a third object here. Okay, no need to put like this box obj2. I'll say box obj2 dot volume, box obj2, and within here itself I can give values. Okay, I'll say 3, 3, 3. So okay, when I say you look, just understand the syntax guys here. Okay, when I say box 3, 3, 3, this instead, see over here, new box, this constructor is called. That's why when you print the values are 0. You have to manually assign them using the dot operator. But here, when creating the objects itself, I use the constructor to initialize my fields. So here it will call you have how many arguments you have? 3 arguments, right? So it will calculate this box constructor, which has 3 arguments, and it will assign these variables these values. Okay. Now let me just calculate the volume here. 3 into 3 into 3, which is 27. Okay, this is working fine. So which one do you think is the best approach in all these scenarios? Like, what is the better approach, guys?
Second one.
Second one.
You mean this one?
Yes.
Yes, that is the best approach. Why do you think so?
Because you can customize the value and you can give the value. You don't have to assign the value fixed. A static, you could go the dynamic.
Yeah, here also I can customize the values, right? See, basically the best approach is this one, true, but the reasoning behind it is we should never let our classes variables accessed directly and let them modify values like this directly. This should be never allowed. This is not a good abstraction or a good encapsulation principle. All your variables should be private always. Okay. When I make this private, now let's see what's happening here. You can't access length variable anymore outside of your class. It is giving compilation errors, right? Yes or no? It says box.length is not visible. It is not visible because we made it private. So the best practice is all your data members should always be private. Don't, when you write programming, don't leave them default or public scope. And this method should be public. This constructor and all this should be public because they should be accessed by outside world, right? Putting them private doesn't make any sense. Okay, these should be public. The methods and all, this should be public because these are all the actual behavior. This is the state. So this is how we should be doing it. This is the best practice. Okay. You shouldn't let your variables be what? Public variables and access the using, and you modify the values directly like this. This is not a good practice. This is not a good abstraction or good encapsulation principle. Okay. So this is how you should put all your variables as private and your methods as public, and from outside class using dot operator, you should be able to access these variables only. And if at all you want to assign values, you can assign it this way. using the parameterized constructor. You can do this. Okay. Suppose, let's say you can create another constructor also. Let's assume you have a you can create any number of these classes you want. Okay, let me just close this. We'll stop here, guys. I think it's time. I will stop. Yeah, we'll just stop here. Understood, right? Any queries? Any queries, guys?
Yes, sir, I have a query.
Yeah, go on.
So the box class, while you're creating the type of integer, right? The variables in box class, I see somewhere. Yeah.
Like,
So this integer type, can you have object type?
Sorry, come again. Can we have?
Can we create the object type of variables?
Yeah, you can. If you want, you can make it a double, which will contain length will be 5.2, something like that. If you have a real numbers like that.
Yeah, so this is double and integer. I'm talking about the object type, like real object.
One second, my screen got stuck.
Sure.
Yeah. So what's your question again? Come again. See, within the class you have 3 variables, right? Double, length, height, width. This you can change. This is not a problem. But what's your question? I took it as integer. Explain it. But in real world, this can be a double type or a floating point of data type also, anything, right? Yeah.
Right. In the same way, while creating the variables, so what I'm asking, like we can have the private class length or like something, the class would be the our object one, right? Or I'm talking about the object, real object we have created. We can have the length. Here we have given very minimum, like a length would be, right? Yeah. Can you have that type of object, a variable?
This one you mean to change?
No, the box class, the variable type.
This one?
Yeah.
This is just a name, right? You can give it anything. This is not an integer or type. This box object is a name. The type of this box object is, it is of type box class. As simple as that.
Okay.
This is just a name. See, I'll just try to put this here for you to correlate it better, right? If you see like this here, right? I can create an object like this also. Now, if you see, right, this box, this length is an integer type. What is integer? Integer is a primitive, which is by default provided for us by Java, right? Yes or no? We didn't created any integer data type, right?
Right.
But if you look at box object, this is the custom box object which we created ourselves. This box object will in turn contain all these variables. Okay, this is just a reference.
Okay,
this is the type.
this is what I was asking. So we can create the object. Yep, perfect. Got it.
Inside the box, you can definitely create. It can have reference to its own object also. Definitely, this class itself is like nothing but indirectly you're creating a data type only. Okay. Any questions other than this?